Just looking at some more algebraic fractions, simplifying them. Exercise 1D, Cambridge. Question 8E, simplify the following there. What should we do to start, do you think? Or did you just go common denominator? Or notice that one denominator is the exact opposite in sign to the other denominator. So the quickest way to do this would be just to pull out a negative here, like that, but then I'm going to put that negative on the numerator. So let's see, minus m plus n. If I put that minus, because a positive divided by a negative is a negative, if I put the minus on the numerator, I can go plus negative n over m minus n. Really, what is my, isn't it just m plus minus n, which is m minus n over m minus n, which is 1. That is the quickest way to do this. The other way you could have done it is go common denominator. You should have got 1 anyway if you do it the other way. But look at the denominators. One's the exact sort of opposite in sign to the other. Pull the negative out. See, you can pull the negative out on the bottom, the denominator or the numerator. I've shown it to you in 2 steps because a positive divided by a negative is a negative, or a negative divided by a positive is a negative. So then I've put the negative up on the numerator, but plus minus is just minus. See, now that my denominator is the same, you know, we go m plus minus n, which is just m minus n. That's probably the best way to do that. Question 8F is to simplify the following. X minus y, probably a similar thing happening here. Okay, so we try and factorize the denominator. You can do a crisscross if you want. I'd say y. There's got to be a 2x and an x. You need plus 2xy minus xy. So we've got x plus y over y minus x times y plus 2x. And if you do that, you should check it, just checking y squared plus 2xy minus xy minus 2x squared. Yes, that's correct. Again, we have that same negative thing happening. We can either change the numerator to mirror the denominator of the y minus x. So I'm going to change the numerator this time and make it minus y minus x. Let's just have a look. Minus y plus x, yep. The best thing to do, if you notice they're exact opposites, just change one of them, make it look like the other one, put the negative out the front and check. Over y plus 2x. And our y minus x's cancel and we've got negative 1 over y plus 2x. There are 2 ways you could do this. One way is common denominator on numerator and denominator, but the quickest way is to multiply, everything, the numerator and the denominator, by the same thing. What I might do, I'm just going to leave that one for a sec. I'm just going to do another question just to show you the technique. So just keeping that there for a sec, I'm going to do 9b here, and I've got 2 plus a third over 5 minus, actually no, I won't do that one. I'll do 9c, which is a half minus a fifth over 1 plus 1/10. Now, I'm not going to do common denominator. I know that you could do common denominator, but I'm not going to do that. What I'm going to do, I'm going to look at it. What is the lowest common denominator of the 2, the 5, the 10? 10. So I'm just going to multiply the numerator and the denominator by 10. So I'm going to multiply the numerator and the denominator by 10. So I'm just going to show it here by just writing it like this, but I don't normally show it like this. I just start, right? Do you agree that's what you would do? If I remember with fractions, you can multiply the numerator and the denominator by the same thing. Now, what's 10 times a half? Half of 10. 10 times 1/5, 2. 10 times 10. 10 times 1 is 10. 10 times 1/10. How quick and easy is that? Equals 3/11. Okay, so what I normally do, I just look at it and say, right, I'm going to multiply the numerator and the denominator by 10. I'll multiply that by 10, that by 10, that by 10, that by 10. 10 over 2 is 5. You can jump straight from there to here. But you should say multiply through by 10, or multiply numerator and denominator by 10. A fifth times 10 is 10 on 5 is 2. 1 times 10 is 10. 1/10 times 10 is 1. See how quick and easy that is? We're going to use that same idea with this question. Okay, now let's go. What are we going to multiply numerator and denominator with? By. What's the lowest common denominator of all the denominators? X bracket x plus 1. So we're going to multiply numerator and denominator by x bracket x plus 1. What will the first term be? X bracket x plus 1 minus, if I multiply this by x bracket x plus 1, what do I get? The x plus 1's cancel, I get x over, multiply this by, so I'm just going to put here that I multiplied and up numerator and denominator by x bracket x plus 1. That's what I did, alright? If I multiply this by x bracket x plus 1, don't I just get left with the x plus 1? Do you get that? If I go x plus 1, and what about this one? If I multiply this by x bracket x plus 1, what am I left with? X bracket x plus 1, I'm left with x. Do you see that? How easy is that? What have we got? X squared plus x minus x over 2x plus 1, which is x squared over 2x plus 1. That is the quickest way to do it. Question 9H. We want to simplify this, or, yeah, simplify. Look, what's the lowest common denominator? Yeah, xy. So we're going to multiply numerator and denominator. This is what we're doing. Multiply numerator and denominator by x times y. That's what we're doing. All right. If you multiply this first one by x times y, the y's cancel, and what do you get? X squared. You're multiplying it. Look, if you want, I can write it out again. Xy times x over y plus y over x xy times x over y. If you're going to write it like this, probably a good idea to have that xy next to the numerator, because you can see it. If you multiply xy by this, the y's cancel and you get x squared. If you multiply xy by this, the x's cancel and you get y squared. If you multiply xy by this one, you get x squared. And if you multiply xy by the y over x, you get y squared. Now, it says to factorize, simplify. We could just x squared plus y squared over, you can factorize the denominator, x minus y, x plus y. There is no cancelling here that can happen. Please do not go cancelling this x squared plus y squared with this x plus y. You can't. And x squared plus y squared is not x plus y in brackets squared, because x plus y squared, you tell me what it is. So you cannot write that x squared plus y squared is x plus y all squared, because it's actually x plus y squared minus the 2xy. So please, you can't simplify from there. I did factorize, but there is nothing to cancel. All right. From exercise 1D, I'll get to that in a minute. It says expand x plus 1 on x all squared, and if x plus 1 on x equals 3, evaluate x squared plus 1 on x squared without attempting to find the value of x. Now this question gives us the relationship between the expansion of this and x squared plus 1 on x squared. That's what we'll be doing. So let's just expand x plus 1 on x squared. So x plus 1 on x squared, you tell me what it is. It equals what? X squared plus 2 times x times 1 on x plus 2 times that plus 1 on 1 squared, which is 1 on x squared. Now I've expanded that. Oh, let's simplify. So it's x squared plus what? What cancels? 2 plus 1 on x squared. Okay, that's what x plus 1 on x all squared is. Now it says evaluate x squared plus 1 on x squared without attempting to find the value of x. I'm just going to write this down here again. So if I want to, for part B, evaluate, sorry, this is the answer for A. Sorry, I need to just fix this focus. Now I want to evaluate x squared plus 1 on x squared. So x squared plus 1 on x squared, isn't it x plus 1 on x all squared minus 2? Do you see that? X squared plus 1 on x squared is this left-hand side minus 2. So that equals x plus 1 on x all squared minus 2. Can we see that? This is my expansion. If I want to evaluate x squared plus 1 on x squared, I just take the plus 2 over, minus 2. So it's the left-hand side minus 2. Now, it says if x plus 1 on x equals 3. So this value equals 3. So what do I do here? So that's 3 squared minus 2, which is 9 minus 2, which is 7. So x squared plus 1 on x squared equals 7. 1e, cubic identities, factorize this. What do you think? We've got 6 terms. We're either going to do 2 lots of cubics or 2 lots of, well, anyways, what do you think you might do with these first 3 terms? Take the a, maybe a cubed out? Let's try that. So that equals, take the a cubed out, and then what have you got? Plus a plus 1. This is looking good. You know why? Because these last 3 terms are a squared plus a plus 1. And what do you think I fill in? So to get those 3, I just put a plus 1. Are we okay with that? So 6 terms, you could look at it as 2 lots of 3 or 3 lots of 2s. Do you know what I mean? Probably go with the 2 lots of 3. So the common factor is a squared plus a plus 1, and then you've got a cubed plus 1. So a cubed plus 1, a squared plus a plus 1. And let's factorize the cubic. How do you do that? A plus 1. Do you remember these? So this is a cubed plus 1 cubed. Got it? Is a plus b. A squared plus, not 2ab, a squared minus 2ab, which is minus 1 times a. Do you remember your cubic? Plus 1. Because this is a cubed plus 1 cubed. That's what we're looking at. So it's a plus 1, a squared minus that times that plus the last 1 squared. 1 squared is 1, a squared plus a plus 1. And I think that's fully factorized. Because I can't think of 2 numbers that multiply to give 1 but add up to give 1. And I can't think of 2 numbers that multiply to give 1 but add up to give negative 1. This middle here would have to be a minus 2, or this would have to be a plus 2 to factorize it. You can't. Okay? And last question, AF, is to factorize this. 1 plus x squared over 1 minus x cubed. That doesn't need to be in brackets, by the way. Plus x minus x squared over 1 minus x all cubed. So this first one doesn't have to be in brackets. This is 9f. I cannot factorize that. And you might want to write it the other way if you want it as x squared minus x plus 1 if you want, but you don't have to. 1 minus, this is 1 minus x cubed, no bracket, sorry. You can't, actually that is 1 cubed minus x cubed. You can actually factorize that, so 1 sec. Minus x cubed, it's really 1 cubed minus x cubed. So think of it as, it's 1 cubed minus x cubed. I just got that over here. That's what that is. It's different to this. So how do we factorize that? That's a difference of 2 cubes, isn't it? 1 minus x, 1 squared, which is 1, plus 1 times x is x plus the last term squared. Plus, factorize here, x bracket 1 minus x over, you cannot factorize this, 1 minus x cubed. So, well, just making sure I wrote it out right. And I didn't. I've made a mistake. This is a plus, thank goodness. Right, that's much better. See, that's a plus there. Makes it a lot easier. What are we going to do next? This is a plus. Now, if I put a bracket around this, I am, I'm allowed to cancel because it's 1 minus x times this bracket. This can be in a bracket. I can cancel these. So, I've got 1 over 1 minus x plus x. Oh, yeah. Ooh. No. Yes. Yes, you can. The 1 minus x can cancel with one of these, and I've got x over what? 1 minus x squared. Great. Brackets around the outside. Okay, now what do I need to do? The first, what's my lowest common denominator? 1 minus x squared, not cubed, squared. So I'm just missing a 1 minus x here, aren't I? So I'm going to multiply this first fraction by 1 minus x over 1 minus x. Now I've kept them separate at the moment. Now I can write it all as the one thing. My denominator is 1 minus x all squared, and I've got 1 minus x plus x, which is? Okay, 1 minus x. I didn't have to put that in brackets up there because it's not being multiplied by anything. But it's 1 minus x plus x is 1.